The number of queries we get these days about genetic testing and penetrance is increasing, and so our next talk should be of great interest. We should have been hearing from Kathryn Robson, Dr Kathryn Robson, a researcher and geneticist at Oxford Weatherall Institute. But Kathryn has unfortunately broken her leg, and although she's here with us today and very interested, she can't stand for long periods. So we're extremely fortunate to have our colleague Dr Patricia Bignell here to talk to us. I heard Patricia speak on this subject a couple of weeks ago, and a very interesting and informative session it was. Patricia has also published papers on the effects of iron overload, so over to you, Patricia.
Well, I'll start anyway till he gets my slides up.
My apologies.
You can do the talking. We've got a couple of brownie points by what the other people have been saying. We are a centre of excellence for red cell disorders, and of which a huge part is hemochromatosis and iron disorders of iron regulation. And it is run by a hematologist, two hematologists who have got a very good, big interest in red cell disorders. And we get referrals from all over the country. Dr. Wally Atobi will be happy to see anybody from anywhere. We've got a family coming from Botswana next week, so they come from everywhere. So as you can see, we kind of used David's title, but we thought ours was a wee bit better. But hemochromatosis is more than YY homozygotes, which a lot of you probably know. And I'm going to talk about what we do in Oxford and the testing we do. Right, this is just about our lab and how we developed. As you can see here, these green lines indicate when the first paper was published assigned to a mutation in a gene. And as we mentioned previously, 1996 was the breakthrough. That's when the HFE gene was found, and the two mutations, C282Y and H63D, was assigned to iron overload or hemochromatosis. And it is a North European mutation, or Celtic or Celtic or whatever you want. I must admit we didn't vote for the green team, we were the other one. And over the next 20 years, just till the beginning of this year, the latest gene has been found with mutations, and that's BMP6, and that's been associated with mild to moderate late onset hemochromatosis. So even today there's more genes being found and more mutations associated with iron overload. So in 1996 the HFE gene was found, and then that was when Kathryn started to do the HFE genotyping, and she got a lot of patients from over the UK because the service was free. And then in 2006, it was passed to the diagnostic lab. And as usual, when you ask clinicians to pay, the numbers drop down. They don't like paying for anything, but we're now running about $550 a year, of which about 20% are YYs. Not all of them are symptomatic, but we have a lot. And then we have a smaller percentage that are compound heterozygotes. That's they have a mutation in the 2 exon C282Y and H63D, and then we also have homozygous DD, and some of them do have a phenotype. It's not as benign as some people make it out to be. And then in 2012, with the advent of new technology, we introduced Nextgen Sequencing. And we introduced that in 2012, and we had about 100 patients screened, and to the end of last year, we're now up to about 200 patients. I'll explain what all these are in a minute. So most of you have gone for genotyping. So that's a straightforward, easy test. You get some blood, they extract the DNA, and you usually get a gel like this. So that's the C28Y there, and that's the H63D there. If you're YY, you will have a picture like this. If you're CY, you have a mutation up there and down there. And if you're homozygous, DD, this is your picture. This is what most people come for first, and you'll get an answer. You're either homozygous YY, or you're a carrier, or you're compound het. I took some inspiration from the website, so I hope you don't mind. I thought I'd brighten it up a bit. So 80% of the hemochromatosis, I hate these things, are due to homozygous 282Y. However, a small number, as I said, are compound hits or homozygous 863D. 10% of cases have not got them. They're rare genes. And they're usually, well, we found usually they're one of 4 other genes as well as HFE. They're either ferroportin, hemojuvelin, hepcidin, or transferrin receptor 2. And it was quite interesting, you saw Paul, he was actually diagnosed in Oxford and he's got ferroportin disease. So we do have some good after all, you know. And then 26% of our patients are what we call digenic inheritance. That means that you've got a mutation from 2 genes, which by themselves don't cause an effect, but when you put them together, you have an iron overload phenotype, and I'll show you that later on. 5% are due to mutations in unknown genes and all novel combinations. And through all this work we're doing, we're able to understand iron hemostasis a lot better, or try to, but there is a lot still to be discovered. What happens when you're not YY? You probably get told you haven't got hemochromatosis, and I bet some of you have been told that. Well, that's not true. You can get, you can get expressing heterozygotes, so that means you only carry 1 copy of the mutation, but you actually have a phenotype. You can be expressing normals, which means you do not have a mutation at all, but you're expressing an iron overload phenotype. This doesn't mean that you haven't got hemochromatosis, it just means you haven't been screened for the right gene. These are all the genes, so you try and pick which one you want. You could be one of them. This is where we come in to help. So these are the 5 common genes that we find mutations in. There's the HFE gene, which is the one that most of you get screened, but there's other mutations in that gene. Very few labs actually screen for them. You get the juveniles, which are very severe conditions, early onset. We'll touch on them later on. You get the transferrin receptor 2. Again, they're all fully penetrant. And then you get ferroportin disease. There's 2 types. You get hyperferritinemia with this one, or you get hemochromatosis with this one. They're autosomal dominant, so you only need 1 mutation. So the future is targeting next-gen sequencing, which I do, and then we are going into whole genome sequencing. This will make you look like aliens in that picture, but we're doing that. This is where we're moving to try and find new genes. So what's the advantage of next-gen sequencing? It allows us to do, we've got a 16 gene panel, so we can put patient on that gene and we sequence 16 genes in one go. So we get an idea of what you've got. It's not piecemeal, we just do the whole lot. And it's easy to do, and it's very cost effective, and we can do iron overload genes, iron deficiency genes, and other genes where there is iron overload in other parts of the body, and hyperferritinemia cataract syndrome. So there you are, a picture of everybody getting done at the same time. These are the genes that we do. We've got a whole 16 of them. The testing pipeline, most people have gone through the HFE genotyping, and it isn't an acquired disorder. Some conditions think it is. It isn't. They're usually referred because they're not YY. They've got an iron overload, they've got hyperferritemia, iron deficiency, and there's other ones. And the latest category last week was weird. So there you are. 16 gene panel. You either find a causative mutation or you don't, and then we go on to look for deletions and duplications. So that's part of the genes being taken out or is being duplicated. And then if you get either 2 answers, it's either normal or you find a mutation. We then do a technical analysis pipeline and a clinical analysis pipeline, and we do an MDT. So we are up there. And we report, and then we send out the reports to clinicians, and then we get the phone call saying, what does this mean? Well, some of the genes that we do are found 1 in 2 million, so in the population of about 60 million, there's 30 in the country. And usually most hematologists or clinical geneticists only see it in a book when they're learning to be doctors. So actually to get one in front of you is very rare, and they do need some help. This is why we set up the Centre of Excellence, so we can help not only the patients but sometimes the clinicians. So we're going to look at the clinical analysis. This is what I do. So 28% of our patients don't have a mutation, 24 are carriers, but we actually have found a causative mutation in 48% of the patients. And of that, 26 have got mutations in more than one gene. And these are the diseases we've got. There's hemochromatosis, which is an iron overload, hyperferritinemia in juveniles, and other diseases. So I'm just going to focus on juvenile and hemochromatosis. So hemochromatosis consists of 3 genes. HFE, type 1, which is your HFE gene. Type 4b is the ferroportin. And type 3 is transferrin receptor 2. These are just some of the other mutations in that gene. Most of them are in combination with C282Y. As you can see, there's a whole lot of different mutations. Briefly, the red ones are non-Caucasians, so they're other ethnic groups. These are novel ones that are highlighted in bold. And then homozygous, which you'll see later on, are usually in the juveniles. But you can see there's a whole range of mutations. Unless you actually do the whole gene screening, you won't find them. And we've actually got a de novo C282 phenylalanine at the C282 site as well. Hemochromatosis, the type 4b, which is ferroportin. Again, we've got a whole range of them. We'll get a few more non-Caucasians, but you can see there's a whole range. This one's common in the UK population. And then transferrin receptor 2. It's rare, but we've actually got 3 compound heterozygote families, so that's 2 different mutations. And this chap from Afghanistan, he's homozygous. So we've got a whole range of mutations that cause iron overload. The juveniles, these are very early onset, very severe, highly penetrant. Males and females are affected. You get 3 types. You get type 2b, 2a, and type 3s. If you look at the 2a's, that's the hepcidin mutation, gene. Again, we get a range of mutations. Again, these are the Asian families. But when you get to type 2a, this is the most common type of juvenile we've got in the UK. This one here, G320V, is the Caucasian mutation, homozygous. We find that in Britain and all the other European type countries. This one here is the Pakistani mutation. And what's interesting about between the Pakistani families, or the Asians, and the Europeans actually get iron overloaded in their hearts. Pakistanis don't. We had a 21-year-old with that mutation who went into the hospital with pain. As you mentioned, you get pain. And he was told it was growing pains. He died several hours later. We had another one just recently. The only reason he went to his doctor was he lost his sexual function because he had a new partner. But he'd been feeling unwell for months and months. Juvenile. We had an Indian lady who had uncontrollable diabetes. Juvenile. We had another lady that came in with severe periods. She was tested because they thought she was anemic. She would be anemic. Juvenile. Her twin sister who didn't have, identical twin sister who didn't have the periods, she had a more severe phenotype. As you were saying about your hemochromatosis, they get seen at different modalities. It doesn't seem to be getting picked up early, and people are dying because they happen really early and they get very severe overload. It's not just your heart, they've got their livers, they get the joints, they get infertility, they get diabetes. It's really quite bad, this disease. And as you'll see in the type 3, how bad it is. This is a 31-year-old who's got 2 novel mutations in the transferrin receptor 2. They're really rare. He was out shopping with his wife. And the full story is this. He's also CYHD. He died with 3 times with cardiac arrest before he even got into hospital. He's severely iron overloaded. He had cardiomyopathy, iron deposits in his heart. He was going to be blue lighted along the M4 to the Brompton for a heart transplant because they thought he was going to die. And it wasn't until they were waiting for him to stabilise did somebody take his blood. And that sample was taxied down the M40 to Oxford to get tested. I tell you, I've never seen a hospital react so quick in my life. But so when we phoned them up and said, we think this is juvenile, Kathryn and half the clinicians in the UK got a phone call saying, how do we treat this patient? They don't know, because it's very difficult and it's very rare. And it took over, what, 18 months, 2 years for him to get all the iron out?
They got his iron out very quickly.
Did they?
But he's on severe maintenance therapy.
Yeah. And he still doesn't know whether he could father children because the iron was that severe. We get rare mutations. I haven't put all the other diseases on, but as I was saying, the BMP one is the new one that's come out. And we are finding it, which is quite surprising. And we've got another 15 other patients with other mutations in the BMP6 gene, but we have to get functional studies done on them before we can see whether they actually are causing the disease. These are the deletions and duplications I was telling you about. We've got quite a few. We've got one in the ferroportin, and then these other ones are significant as well. But if you can see here, this is the transferrin receptor 2 patient. He's got a deletion here. And then this is the other lady that's actually got a huge deletion. She's actually got 76 other genes missing. So what's digenic inheritance? This is very complicated, and it gives me and the clinician a headache sometimes, because it's very difficult sometimes to explain to a clinician how the patient's going to fare. So basically, you could be a carrier in one gene. Usually when you're a carrier in one gene, you don't get an effect. You're normal. But when you get a carrier in this gene and this gene coming together, you get an iron overload phenotype. So the two carrier mutations have actually joined together and they're given an effect. And again, you can get a HAMP gene with C282Y or C282Y with transferrin. There's loads of combinations. You can also get ferroportin with HFE gene. We've actually got a lady with 3 mutations, and that report was quite funny to write, trying to predict how it was going to affect. So these are all the combinations we've got. This is the lady with that one, and then you can see they're all there. So what happens with the patients with no mutations? We actually have 151 with no mutations, of which 38% have an iron overload phenotype, 48% have hyperferritinemia. The rest of the samples are carrier analyses, and we've got iron deficiency. We've got some really odd patients from Nepal who don't have anything, and what we're hoping to do is, for these patients, is go through whole genome sequencing, but that will take a wee while to put through, and the cost is coming down, but it's not coming down fast enough for a diagnostic lab in the NHS, but we'll get there. We can also utilise the 100,000 genome project that they've instigated in this country and other countries to have a look at everybody's genotype and see what SNPs and mutations are actually in the population. So hemochromatosis is more than the YY gene, C282Y homozygote. The genotype appears linked to ethnic background. Many of the non-Caucasians, if they've got severe early onset iron overload, they usually, I would test HFE2 and HAMP first. And also the Caucasians. Ferroportin, HFE and TFR2 are mainly found in the Caucasians. Majority of patients have mutations in the 5 genes, but there is rare genes as well. And we find that digenic inheritance counts for 26% of our cohort of patients. And hemochromatosis is not a monogenic disorder. Please tell clinicians that, because it isn't, because digenic inheritance is a major player in hemochromatosis. And we've had funding from the Hemochromatosis Society, Oxford Biomedical Research Centre. That is our website there. Not as if I'm touting for business, but that is our website. And we'd like to thank the patients, the clinicians, and our colleagues at the Molecular Haematology Lab in Oxford. Thank you.